Alright, hello everyone. So let's finally do trigonometric substitution integration. Okay, so this is the problem I want to solve. Now what I'm going to do in this video is I am going to solve this problem very slowly and step by step. So pay attention, and I'm going to explain the mistakes that you are going to likely do when you're solving a trigonometric substitution problem. Okay, let's get started. Now the most important thing in a trigonometric substitution problem is the square root part, right? I mean, that is why we spend couple of videos learning about the square root part. Okay, so let's look at the square root part. So it's square root inside 4 minus x square. So you look at the square root type and you go back to that table and decide the appropriate substitute. So our square root part was 4 minus x square. Okay, now if you look at the square root part, it's look like it's this third type, right? Your a square is 4 and you have subtraction and you have x square here, so it has something to do with sign. So that is what you need to first identify. Okay, now what is a? Decide a very carefully, because if you choose wrong a, then you're gonna mess up the whole problem. So what is a? Now here, if you look at the square root, so here you have a square, so this is supposed to be a square. So if a square is 4, what is a? A is 2, right? Because 2 square is 4, so a is 2. So a is 2 here. So the correct substitute is x is equal to 2 sine theta. Okay, take couple of seconds and make sure you have the correct substitute, because I mean that's the very first step, right? Good. So here the substitute is x is equal to 2 sine theta. Alright, now then let's see what we are going to do. We are going to substitute x, or these theta terms, in the place of x in the integral, right? Now actually, even though we say this problem is trigonometric substitution, it's actually integration by substitution, right? You change the variable. Instead of x, you are going to change x to theta, right? Because eventually, right now what we are going to do, not eventually, right now what we are going to do is we are going to replace x by this theta term. Okay, in integration by not parts, in integration by substitution, there's actually two substitutions that happen, right? One is that you normally substitute x here, but you have to change dx also. That's the most important part. Don't forget that. Okay, you don't just substitute x by this part, you have to replace this dx also. Okay, remember I said when we were learning integration by substitution is actually two-step method, actually two substitutions, right? Okay, so how do you replace dx? Well, you have to find dx in terms of d theta. So differentiate x, dx over d theta. Okay, so differentiate x with respect to theta. So 2 times derivative sign is cosine theta. That's important. So what is dx? Dx is 2 cosine theta. Let's take the d theta to the right. So this is what you have. So you need both of these statements before you proceed and substitute. Okay, remember that. I know most of the students forget this step and automatically replace dx by d theta without having this cosine theta term, or without having the appropriate term that is here. Okay, so that's wrong. That can mess up the whole problem. Okay, now you can do the substitution. So let's do it. Okay, so it's 1 over square root 4 minus x is 2 sine theta, so x square is 2 square is 4, sine square is sine square theta. Make sure you square both of them. Okay, alright, now dx is 2 cosine theta d theta. This is the correct way to do it. Alright, now what you're gonna do, now once you are finished with substitution, okay, make sure you don't have x anywhere else in the integral. So if I look at the integral, well, I have only theta, so you're good with the substitution. Make sure you have substituted it correctly. If you see x still in the integral, that means you have not substituted correctly. That means you still have to do some substitution. Okay, so now here everything is in theta. Good. Next thing you want to do is you want to handle the square root. How do you handle the square root? Just like I taught you in the very first video. Okay, don't get rid of the square root right away. Do the simplification. Here I can take out a 4 inside the square root. So this is 1 minus sine square theta. Here 2 cosine theta d theta. Okay, now you can use Pythagorean identity. Don't be in a hurry to get rid of the square root. Okay, so 1 minus sine square theta is actually cosine square theta. Okay, because cosine square theta plus sine square theta is equal to 1. That's the Pythagorean identity. So if you take this sine square theta to the right, cosine square theta is actually 1 minus sine square theta. Okay, and don't drop these terms. Okay, that I have seen too. Students drop these terms or forget those terms. Do not do that. Okay, all right. So now take the square root here. Now get rid of the square root here because you don't have any addition or subtraction inside the square root. Now square root of 4 is 2. Square root of cosine square theta is cosine theta. Okay. Now once you get rid of the square root, simplify your integral as much as possible. That means you might be able to cancel certain terms. Of course, yes, here 2 cosine theta cancel out. So what's left? 1 times d theta, just d theta. Now integrate. If you integrate d theta, if you integrate 1 with respect to d theta, okay, not if you integrate d theta, if you integrate 1 with respect to d theta, you get theta plus arbitrary constant c, right? Okay, so now you're almost done. Now you started your integral with respect to x. Now you have your final answer with respect to theta. Now what you want to do is you want to replace theta by x. You want to present your final answer in terms of the original variable, which is x. Now how can we do that? Well, always remember you do that using the substitute. Okay, this is the simplest case. I'm going to explain a non-trivial case in the next video. Okay, in this video I'm going to do just one problem. So use your substitute always. So substitute is x is equal to 2 sine theta. So then what is theta? Well, let's make theta subject. Divide by 2. So sine theta is x over 2. Right, I took this 2 to the left and flip the sides. Now how do you find theta? Yes, take the sine inverse of the right hand side. So theta is sine inverse x over 2. So replace it here. So here you have theta, so sine inverse x over 2 plus c is the answer. Okay, so this is what we get if you integrate, if you solve this problem. Okay, now before we finish off, I want to show you key steps in a trig substitution problem. Okay, just to make sure. All right, first thing first, choose the correct substitute. That's the first thing you want to do. Okay, all right, be careful with choosing A. Okay, all right. Next thing is, remember that substitution involves 2 substitutions actually. One is for x, one is for dx. Make sure you do that also. All right, differentiate your x, differentiate your substitute and get dx. Okay, replace dx by whatever you get. All right, the third key step is, okay, the third step is to substitute everything. Replace dx, replace x by those theta terms and check your integral. Make sure in your integral you don't have x any longer. You only have theta. Okay, make sure that. All right, here I'm good. Fifth steps is to simplify the square root. Just simplify the square root. Don't worry about the other things. See, I didn't even look at these things, but I wrote them. Okay, remember I keep writing them, but I only work with the square root. You cannot get rid of the square root right away. Do the simplification as we learned in the first video. Pull out the common number, use the Pythagorean identity. Now take the square root at the final step. Okay, the fourth phase of your problem is to simplify as much as possible once you are done with the square root. Once you are done with the square root, hopefully you will get a simpler term, and then you might be able to cancel certain terms in your integral. Okay, before integration, cancel them, simplify them if possible. After that, once you simplified, integrate. Okay, so that's the obvious step. You have to integrate, and then the final step is to replace. Your answers will be in terms of theta, definitely. Replace them in the original variable. Original variable in this case is x. So use the substitution to do that. So that's the 7th step. Okay, all right, this is a very easy problem. In the next video I'm gonna do another different type of a little complicated problem, so make sure you watch that video also. Okay, I'll catch you there. Thank you very much.